Awesome. Thank you, Toby. So good morning, ladies and gentlemen, and thank you for joining us here today. My name, as Toby mentioned, is Thomas Davis, and I'm the Director of Analytics at Core Power. Now, Mikhail mentioned Core Power's goal is to deliver innovative energy solutions tailored to some of the world's most energy-intensive and hardest-to-abate sectors. And today, we'll focus on one such industry that is deeply rooted here in Texas, oil and gas. The industry faces a challenge in scalability, demanding an energy solution that can power its vast and unique operations, often in remote and offshore locations, while maintaining energy efficiency and reducing its greenhouse gas emissions. The industry, and that brings us today, to our topic, floating nuclear for offshore oil and gas. So to put that into context, it's important to consider the broader global energy landscape. Despite the rapid growth in renewable energy and the global shift towards cleaner resources, in a world of ever-increasing energy demand, oil and gas remains critical components to the world's energy supply. Today, these resources account for over half of our global primary energy consumption and have been essential for economic stability and energy security, especially during times of rapid load growth or market volatility. As a result, projections now suggest that a peak in oil and gas demand may not occur until as late as 2040, underscoring its continued relevance in our energy system. However, the industry is not without challenges. It faces rising operational costs, shifting market dynamics, and increasing pressure to decarbonize its operations. To stay competitive, the industry is actively exploring innovative energy solutions to enhance operational efficiency while reducing dependence on fossil fuels to power their operations. When assessing future solutions, they must consider several key criteria that define this energy-intensive sector. First, energy demand and reliability. The industry operates in some of the world's most remote and offshore locations where building traditional power infrastructure is costly and difficult. At the same time, the energy needs are enormous. For instance, US oil refineries consume over 1,800 terawatt hours annually. Offshore platforms and FPSOs can demand up to several hundred megawatts when combining their thermal and electrical requirements, often relying on combusting refinery gas or other fuels to meet their energy needs. Notably, older refineries may use up to 20% of their own feedstock solely to power their operations. Second, economic competitiveness. To remain competitive in this global landscape, companies must diversify their energy strategies, integrating alternative energy solutions that ensure long-term resilience and efficiency. And lastly, the environmental imperative to decarbonize remains. The sector contributed over 5.1 billion tons of CO2 equivalent in 2022. About 15% of all global energy-related emissions. Leading companies have now pledged net zero Scope 1 and Scope 2 emissions by 2050. Now, ensuring these priorities will define the success of this sector's transition to a more efficient and sustainable future. Now, in response, the industry is actively pursuing innovative solutions, focusing on optimizing operations, minimizing energy waste, and modernizing its power systems. For example, many are looking to electrify their operations. Shifting upstream production facilities to electric power may reduce CO2 emissions by up to 75% by 2030, while also reducing a continued reliance on their feedstock to power their operations. However, offshore facilities will face significant hurdles in implementation, such as limited grid access and harsh environments. Carbon capture, utilization and storage is also a promising pathway the industry is examining to reduce its emissions. However, CCUS itself will require a steady energy source to operate at any scale. Now, while some operations can be electrified, many processes, including refining, enhanced oil recovery, and natural gas processing, depend heavily on high-temperature heat, which today often comes from burning fossil fuels, directly removing these products from the sale pipeline. Alternatives like hydrogen are under development, but again, they too will require a reliable power source. A key takeaway, to operate at scale, many of these solutions will depend on a localized, dispatchable source of energy, both electrical and thermal. Without it, advancements for this industry will be slow, expensive, and incomplete. And here is where we think nuclear can play a role. Nuclear energy is a proven, reliable power source capable of meeting the high energy demands of offshore and remote operations. Traditional nuclear power plants have long delivered low-carbon, dispatchable energy, with the US reactor fleet operating at an average of over 90% capacity factor last year. However, conventional nuclear facilities continue to be plagued by challenges such as high capital cost and long construction timelines, and this has made them unsuitable for offshore or rapidly deployable applications. Now, to overcome these limitations, the industry has begun to turn to small modular reactors, a versatile and scalable nuclear solution. These reactors can generate both thermal and electrical power like their predecessors, and their modular design allows for faster and novel deployments. With capacities ranging from a few to several hundred megawatts, they are capable of supporting anything from small offshore rigs to large industrial clusters. Floating nuclear power plants take this innovation a step further, leveraging shipyard manufacturing and deployed near offshore platform or coastal sites. FMPPs could provide an ideal, long-term, behind-the-meter and localized energy source for offshore production facilities and refineries. Now, in this way, nuclear energy can directly address some of the offshore industry's biggest challenges. It can provide a scalable and flexible solution centrally located near production facilities. They can provide energy to multiple assets at once, powering independent microgrids in areas of high demand. This can ensure a consistent and stable energy supply, even in remote offshore locations. It delivers dual utility, both electric and thermal energy, both of which are critical for oil and gas operations. This dual capability could reduce emissions, boost process efficiency, with up to 40% of generated energy feeding directly into operational savings. And finally, it can offer an economic and logistical advantage, reducing resilience on gas turbines and diesel generators, cutting fuel transport costs, and minimizing logistical complexities, all while drastically lowering its carbon emissions. With stable energy pricing and long-term reliability, it presents a cost-effective, future-proof solution for offshore energy needs. So to quickly summarize, oil and gas will remain a crucial part of our global energy mix for decades to come, but the industry faces growing pressures from operational cost rising, regulatory demands, and market volatility. To remain competitive, companies are looking to diversify their energy strategies, integrating solutions that ensure long-term resilience and efficiency. The emergence of advanced nuclear technologies deployed in floating nuclear power plants could present a promising solution to these challenges, offering behind-the-meter energy directly to production sites, improving process efficiency and providing a stable, long-term energy price. This positions companies ahead of an evolving market, ensuring goals are met without compromising reliability or profitability. And with that, I'd now like to turn to my panel discussion so that we can understand from the perspective of the experts within the industry how these technologies might be able to address some of the key industry challenges. So to introduce my panel from left to right, we have Greg Schultz, Strategy and Innovation Advisor at ExxonMobil, one of the largest oil and gas companies. I'm sure I don't have to give that much of an introduction. And also Jaap Harmwieses, Technology, Innovation and Product Development Director at SBM Offshore, a company specializing in innovative floating production systems. So if I can begin with you, Jaap. SBM Offshore obviously has significant expertise in floating production systems. What role do you see nuclear energy playing within this sector?
Thank you very much for the introduction, Thomas. And well, good morning, everybody. Let me start by disqualifying myself as a nuclear expert. I guess many of you here in the room have some background in Navy or submarines or direct nuclear technology. Unfortunately, I have not. To answer your question, Thomas, maybe I can take a quick moment to introduce a little bit what SBM Offshore does and how it's relevant to the discussion that we're going to have about industrialization and bringing large industrial technology offshore. So SBM designs, owns and operates FPSOs, floating production systems, which are deep water industrial floating assets that produce oil and gas for our clients. Now, these are among the most complex and largest floating industrial structures in the world. I mean, these are vessels that carry capacity of 2 million barrels of oil. They produce, the newest generations, they produce over 200,000 barrels of oil per day. To do that, they have power facilities, typically, if it would be an all-electrified topside, in the range of 150 to 200 megawatt electrical, which is today powered by the natural gas coming from the wells that the oil and gas is being produced from. These are remote facilities. They're in the middle of nowhere. They're not connected to any grid or other type of infrastructure most of the times. And they are on station for 20 years without any intervention. They don't go back to dry dock for repairs or inspections at such a location. Everything is done offshore. So these are 40,000 ton topsides, metric ton topsides, typical type of facilities. And the reason that we are able to deliver those relatively consistently and reliability in a short time frame is because they are constructed with modular topsides. So that's coming back to your question there. The success of being able to do these very complex things offshore relies to the fact that there's a wide a supply chain of fabricators, module fabricators, of course, together with clients and other stakeholders in the process to quickly integrate and deliver at site. Now, in order for nuclear energy and clearly, or nuclear power or nuclear heat, to be successfully integrated to that, it must be modular in that same context. So where we have today 2 or 3 or maybe even 4 modules out of say 12 that are responsible for the power generation, this could be replaced by nuclear power in the future, at least in theory. So the opportunity that it has is twofold for oil and gas companies. So I would say, from our perspective, the most important one is it supports our decarbonization journey. So as today we are emitting quite a lot of greenhouse gases through burning natural gas in the gas turbines to provide the power. We're making steps to capture the CO2, re-inject if possible, which is a big if, to do a big reduction step. But if we want to go forward in the next decades of really providing low to almost zero emission oil production, we'll need to look at alternative power sources. So this is an opportunity. Now, there are many other opportunities which I think we'll talk about later, but this is where we're coming from in this area.
Yeah, no, brilliant, thank you. And then maybe Greg, from ExxonMobil's perspective, I guess as a global operator, what types of applications then or assets do you think are most suited, I guess, to nuclear power?
Yeah. Good morning, everyone. A couple comments I just want to lead off with. So power and heat are critical to all of our operations, whether it's offshore or onshore. And we see potential applications in the advanced nuclear space for the heat applications. So if there's one thing you take away from this panel, I really want to stress the heat integration opportunity. Of course, we're interested in the electrical power. Jaap mentioned the FPSOs and co-sign a lot of what he was saying there. In fact, we're close partners with SBM on a number of FPSO deployments operating today and actually on order. But the heat integration is a really challenging part when you look at abating that. We have carbon capture, sequestration. We have hydrogen business lines that we're standing up. Those are going to be part of the solution. But they won't work in every application or in every space around the world. So our view is that it's an all of the above type approach. And so we're seeking to understand how could nuclear fit in to satisfy those type of solutions where it could be competitive. So if I look at the maritime applications, offshore, deep water, remote, not connected to any other infrastructure, typically, the FPSO type application, that is a interesting use case. When I look at the FNPP type approach that's been discussed this morning, I see applications as well for coastal facilities. I think the next panel is about port electrification, right? But I think I want us to think more broadly, right? It's not just the port, but what if it's a large industrial facility, a chemical plant, a refinery, LNG facility. And again, thinking about not just the electricity going onshore, but how you transfer that heat as well, whether it's steam or some other medium. I think there's tremendous opportunities for those applications. And then if I think about actual onshore, if I could just speak on that for a minute, I think there's actually a nice synergy starting with offshore and then translating that to onshore. I've been intrigued with this idea of mega modularization, right? Where you build a module, in a shipyard type environment, and then you do a heavy lift and you place the module on land. We've done this before in some of our projects. Our largest world-class ethane cracker was divided into 6 modules, and those were fabricated overseas, transported to the U.S. Gulf Coast, and then 6 heavy lift modules placed on shore. Why can't you do that for a nuclear power and heat solution? If that can sit on an FNPP, why can't that then be placed on shore if that's the application that makes sense for that solution? So those are the ideas that I'm interested in. Cogen applications, generating the heat, generating the steam, and of course, electricity applications as well.
No, brilliant, yeah. I think, as you say, cogeneration, some of those refineries, the thermal requirements are enormous. Pulling out that thread a little bit then, I guess, in terms of then more practical application or implementation, for those cogeneration applications, what do you see, I guess, as the main challenges or technical challenges with integrating an FPP with existing infrastructure, say?
Sure. We've been looking, kind of assessing nuclear for a number of years now. Our teams have identified potential opportunities where nuclear could be a competitive solution when it's deployed commercially at scale. But one of the challenges is the way that the nuclear industry develops and delivers projects today, right? So the delivery model, if you will. So let me expand on that a bit more. We've looked at how a typical nuclear project or product is delivered, typically to a utility customer. That interaction from project design to the development, the interaction with the EPC, the management of the project. And if I try to overlay that into an industrial application or specifically an oil and gas application, you've thought about some of the projects that our two companies have worked on. I see a lot of friction in how those two work together. That model there's going to be a lot of challenges that need to overcome. So I think there's tremendous opportunity for our industries to work together on that, for the industrial facilities more broadly to come forward and say, this is what we need to see, this is what we would like to see for integrating that nuclear solution into our industrial facility. And again, remember, it's not just the power. If it's electricity only, that's not as difficult, right? That's well understood. We can do that. But when you talk about integrating the heat and the process requirements and the engineering and the technical details and the challenges and the load following and refueling outages and everything that trickles down, there needs to be close collaboration and coordination between the reactor technology providers, with EPC partners, and with the end users ourselves. And that discussion is not happening today. And I think there's a tremendous opportunity for our industries to work together on that. And so there's a number of challenges, but I would like to just start there and say, let's figure out how we can collaborate and solve some of these.
Fantastic. And then maybe from your perspective, I guess, then, what do you see as similar challenges?
Yeah, well, I'm obviously supporting a lot of Greg is saying here. I mean, well, starting with the integrated design approach, right? There's always a little bit of a tension between standardization on the one end and having integrated design approaches on the other end that requires, well, some sort of it. But it is possible, and I think our industry has shown that we can strike a right balance between modularizing and standardizing what is common, allowing sufficient flexibility in the overall integration design to deliver the project-specific needs. And I think that will apply to any future integration of nuclear technology as well, both from the electricity as from the heat perspective. Now, one of the things on floating nuclear that at least I think is pretty obvious opportunity to see is that it is independent of the gas supply, the typical supply of fuels that we're used to in oil and gas, allowing that at least conceptually to be a modular solution or a relocatable solution over different opportunities, and that is something that is a different way to look at also potentially repurposing some of the existing assets that may not have the full lifetime yet to now justify a fuel nuke on independent power supply, but that could benefit from some kind of a collective use of a centralized power facility that can be redeployed to other locations later, being it near shore or at shore. But in order for all that to be meaningful and pragmatic, it needs to be cheap, or at least it should not be expensive. And in order to have that benefit, it goes back to, I think, some of the talking points that Core Power is brought up. You need a standardized supply chain that somehow brings modular experience and building and delivering models that can be utilized through EPC contractors and end clients into various applications. And starting that journey of creating a supply chains and fabrication locations and fabricators and technology providers that can do that requires a form of unified understanding of end clients of what it is that they would like to see in terms of application area of such power, being it onshore or at shore or near shore or even offshore. And clearly there should be only a limited number of modules that we should be selecting from. So this process of thinking about what is it that we have in common and how do we enter that into a supply chain, and then how do we utilize that supply chain to deliver value in our traditional businesses, I think is the crux of the discussion that needs to start in parallel to all the technical and regulatory difficulties that are there.
No, exactly. And I'm conscious of time, but I think we have time for a couple of questions from the room. So does anyone have any questions for our panelists? Yeah, please, gentleman here.
Good morning. My name is Francisco Miller. I'm from Petrobras Research Center in Brazil. I like very much the description that you give about the oil and gas, offshore oil and gas needs, and that's one of our questions because we have been looking at it too. And then I would like to ask your opinion about, do you think it would be possible to just change the models from gas turbine to SMRs and an FPSO, because then we have safety, we have classification things, and or what is more probable, I don't know, having a power hub, having an FNPP. I mean, that's one question that we should address, because the best solution for us would be change the gas turbines by SMRs. But I don't think it's exactly feasible because of footprint safety and all those things. So what's your opinion about that, please?
I'll take a first shot, then I'll pass off. So if you look at one of our deep water developments, we are mass producing FPSOs essentially, right? And so there's at a mega project scale, we are turning them off the assembly line on time, on budget, and doing it really well and applying those learnings. When I look at, if I were to convert that from a gas-powered vessel to a nuclear-powered vessel, I don't want to throw away all those other learnings, right? So that is the goal, that is the objective. It's lofty, but can you just pull off the existing power module, and can you plug in a nuclear power and heat module? I think that's the starting point, right? That's can we make it as equivalent as we can? I know it's not going to be a one for one, and there's other challenges, but we need to start there. From our assessments, I think it's feasible. It's extremely challenging. It's one of the most toughest problems to solve if you look at all the potential applications out there. But it's interesting enough that we should keep going and keep looking at it. I'll say it like that.
Yeah, and maybe to add to that, and just to maybe also clarify a bit your question, I think if you are looking at that in a brownfield context, that would be, probably not possible, or clearly. No. So, but from a greenfield perspective, yes, it will require a full redesign, reconceptualization to take into account all the elements that you mean. But again, like Greg is mentioning, conceptually, in terms of if we have these emergency zones small enough, if we have, conceptually in terms of weight, footprint, and size, and also power requirements and heat control, it should work. Where I'm not so certain yet, but it's areas where we need to, of course, also look, is when it really comes to the operational profiles over the lifetime of fields, shutdown processes, maintenance processes, cold starts, all the, I would say, non-standard operating conditions and how those are affected. But it is what we aspire to investigate as an opportunity once we run out of probably all other options to decarbonize and be more efficient. But the question whether it really is going to be possible, I think, is out there, right? But for me, the real question is, how are we going to answer it? And we for sure need, collaboration and discussion and integration of the technology providers, the clients, the EPC providers, the supply chain, the regulatory bodies to come together and formulate that challenge together as well.
I think we have time for one more question from the audience. Oh, yeah, there you have that.
I am Chick Rock from Gloucester. So much of the value proposition for nuclear and maritime, I think, comes from the idea of economies of scale, doing things modularly, efficiently. And hearing you describe mass production of FPSOs, it occurs to me that you're operating in the end state that we hope to get to. So I'm curious what lessons learned we should be looking to for the future to, not repeat challenges you've already faced, and kind of what insights you have that can help us achieve that more quickly.
Yeah. Well, so thank you for that question, and I think it's valid to see what type of parallel can we draw and what can we learn. So for those who may not know, but standardization FPSO business is relatively new in the industry. I mean, we have come from a past where we are basically converting existing tankers, which are all different, with a lot of bespoke engineering to deliver bespoke solutions to our clients. But that model, is just reaching an end in terms of scalability and reliability and also delivery certainty. So one of the key lessons that our company took from that when we started our standardization model is to, first of all, make it a real program. It's going to take a long time to do that. Then differentiate between what is standardizable or more or less standardizable versus what is likely not standardizable, and not try to standardize everything. Then with what you can standardize, involve our suppliers, our vendors, our engineering subcontractors, our fabricators in how can we ensure that we can replicate what we're delivering in terms of modules over multiple projects, and setting up frame agreements to do that, so that there's also a certainty on their side to be able to be part of the ecosystem. So that those lessons are really providing a standardized platform. Recognize that there are things that will be less standardizable, and just make sure that you cover those in your EPCI phase, and work with your supply chain to be able to deliver the critical components in the standardized modules.
Yeah, great question. I would expand on that to say modularization, shipyard manufacturing. Basically, where is the biggest assembly line that you can build these on? Shipyard, right? It just makes perfect sense to me that you should be building your mega modules in a shipyard type environment. We've seen tremendous success with that. From the project standpoint, it would be very close collaboration, coordination, partnership with our EPCs. When I look at our mega projects, $10 billion plus projects, it's a fully integrated project team with ExxonMobil project team, SBM, other key partners as well. One team working together, very collaborative approach. I'd also say that I think one area that is different from kind of how we do projects is the management of the risk of the project. It's placing the risk on the entity that is most appropriate, that can actually manage the risk, not pushing it all on the EPC, for example. But what risk is ExxonMobil going to take in this project? Do we need to go bring in a partner or joint venture to help manage that risk on our side? So we're very comfortable with different business models. And the risk, our belief is that the risk needs to live with the entity that is most capable of managing the risk. Because if you push it off to someone else, you're not actually mitigating it. It's going to come back to us eventually, and we're going to have to deal with that. So let's be upfront and honest about how we do that. So I think that's another area that has been successful for just more broadly how our industry deploys mega projects.
Thank you. I'm afraid we're out of time, but I'm sure the panelists, if you can find them during lunch and coffee, will be happy to answer any further questions. So I'd like to offer a sincere thank you once again to my panelists. And with that, I'll hand back to Toby.